Here's a quick proof of Thales theorem. I don't know if people will eventually settle on one pronunciation or if it'll remain like lever, umbilicus, malleolus. I witnessed the Kuiper belt being changed to Kuiper belt, so I take pronunciations with a grain of salt. They're oftentimes ephemeral. At any rate, here's the theorem for Thales or whatever. You just got a right triangle right here. Its hypotenuse will pass through the center of a circle, but you don't know where. It's just that center of the circle will be somewhere in that hypotenuse. This is assuming you don't have any measuring device. So if you just want to use like a square that you use for construction, a carpenter's square, maybe that's what they're called. At any rate, you just take your one triangle right here, right triangle. Somewhere around here is the center. You just put another right triangle on there, and its hypotenuse will pass through the center as well. Where they meet is the center of the circle. So I'll show a quick proof on this. Whenever I'm trying to solve some sort of little math puzzle or logic puzzle or a proof, I try to figure it out on my own first because it's more fun that way. And then I usually just check the internet after I figure it out, or if I give up, and then I'll look for the answer on the internet. But at any rate, here's the proof. The reason this works is because what a right triangle is just half of a rectangle or half of a square if you want to be symmetric. So what I'm going to do is just redraw this right here in the form of a rectangle, and you can see that the center will be in the middle of both the rectangle and the circle. This is what it looks like here. If you if you want to make a rectangle or a square inside of a circle, you have to have two chords that are parallel to each other and the same length. Being the same length proves that that center of the circle will be exactly halfway between them, because if you move one chord in or out, then the length of it will change. So we have two chords running this way parallel to each other that are the same length, two chords running this way parallel to each other that are the same length, and that'll prove that the center of the circle is also the center of the rectangle. And these are chords because they don't pass all the way through the circle. If they did, they would be secant lines. So now that we know that this center of the rectangle is right here at the center of the circle, we can bisect this rectangle three different ways. We can bisect it horizontally, vertical, or angle to angle. In all three cases, the line of bisection will pass through the center of the circle. I did a separate proof on this, so you can see that if you want to. Even though it does seem kind of obvious, sometimes things can be counterintuitive, so I wanted to prove that if you go halfway up the hypotenuse of a triangle here, if you go halfway up the hypotenuse, you'll be at the center of the rectangle. So you can see that video if you're interested. But now that we know we've created two right triangles here by bisecting our rectangle, we can simply remove one of these triangles right here, and we can place another triangle somewhere on the somewhere in the circle, and this other triangle can be in a different orientation, and it can also have different dimensions. So it can be a narrow triangle or a really wide triangle. It doesn't matter because the hypotenuse will always pass through the center of the circle. But if we want to leave it as a full rectangle, it would just look like this. One rectangle running this way, one running that way. You can tell they have different dimensions here. Bisecting the rectangles means you're going to have the hypotenuse run through the center of the circle. And it will look like this. Here's a quick tip for anyone that wants to find the easiest way to draw a rectangle inside of a circle and have everything symmetric. Start by drawing a little black dot on the paper, and then that's where you put the pointy thing on your compass to make your circle. I found out if you don't put that black dot there first and you pull up your compass, sometimes it can be difficult to find where that hole is, where the compass went. But now that we have the center of our circle marked, just use a straight edge to make a diameter all the way through it. That diameter will form the hypotenuse of two right triangles. So what we do here is we just simply start at this edge right here where the diameter meets the circumference, measure out 5 centimeters or so for a length to draw a chord from here to here, and then do the same thing, go straight up from here, and then draw another chord going from here to the right that's the same length. And then simply connect your points and you have a symmetric rectangle inside of your circle.